Right. So, yeah, hi everybody. My name is Hermawan. I'm a sales engineer with Solace. I'm based in Singapore, but today I'm actually 1 hour behind. I'm back in my hometown in Binjai, in Indonesia, for the Ramadan month. And here with me is my buddy Jason.
Hi everyone, Jason Abram, sales engineer based in Perth in Western Australia for Solace. So welcome and hope you enjoy what we have to present for you today.
Yeah, cool. So you're happy to hear where you are joining from. Suppose because this is online, not everybody is going to be from Singapore. Let us know where you are joining from. And today we are going to do a bit of a demo of event enabling APIs with what we call an event mesh. Right, so that's what Solace does, and we will talk about event mesh quite a lot in the whole throughout the demo. But before we jump into the hands-on demo stuff, I'm gonna give a bit like 5 minutes intro to give context of what we are doing and why we're doing it. So let's go, Jason. Yeah, so I'll start with this because we want to make sure that we get the key idea that we are not here to clash events and APIs. APIs, RESTful APIs, gRPC, and stuff like that. And now we have events. It's supposed to be working together, complementing each other. That's what we are going to show you today. And just a little bit of definition to kickstart this. Event-driven API is just like an API that we know, but the model, the consumption model, is a push model or subscription model. So instead of we ask for something and get a response in return, we just say that I'm interested in such and such events and just do nothing and wait until the event just comes through when the event happens at the source. Right, just to give some more example on these events. Next slide, Jason. So just to put side by side, Open API specification, the one that we know and love and been using for 5 years or so. You will be familiar with transfer fund, get balance, or book a ride, for example. On the other hand, there's also a specification for the event-based or event-driven API, which is Async API. So please go check it out, asyncAPI.com, if you want to find out more. It's been around for 2+ years already, now reaching version 3. And if you look at the sample of these APIs, it shows that this is a one-way stream mostly. It could be notifications, I think that's the common example, or price updates, campaign offer, or even telemetry data. So that's what we are trying to combine today, mixing both and see how it works. And Jason will walk you through that why we are doing that a bit later. Next slide, please. So a bit about Solace. We focus on event-driven architecture. So this is where we play on the right-hand side. So we know API and we know events and Async API. That's what we've been seeing for the last 3-4 years. And again, it's not meant to be replacing. It's not even replacing SOA and ESB. It's like a big bang situation. It's kind of expanding and implementing new ways of having more resilient, more performance systems, how we design new systems to cope with how traffic has increased and the rise of modern platforms like container and stuff and cloud native. So yeah, so let's hand over to Jason to talk about the demo, the problem, and yeah, let me. Yep.
Excellent, thanks, Ari. So yeah, with the with the the rise of event-driven architecture, we've found ourselves in a position where we do need coexistence of open APIs and event-driven architecture and event-driven APIs. So one of the questions that we want to try and answer today is how do I expose my existing APIs, my REST APIs, as event-driven APIs across sites and potentially across stacks as well. So this is basically the problem on a map that we're aiming to resolve with an event mesh. So what we're looking at here is geographically distributed flight tracking application, and it's also distributed across 3 different cloud providers. So we've got AWS in the US, we've got Azure in London, and we've got the GCP instance in Singapore. So with that in mind, there's 3 instances of our flight tracking app. They all need access to data from the flight tracking API. We've used OpenSky for our flight tracking data for this demonstration. And with the traditional approach of invoking Open API methods, each instance of the application would need to retrieve their own instances of that data to present for their locations, for example. So what that means is as you horizontally scale the number of applications that require that data, you have a linear increase in the invocations of that API. So if it's a paid by consumption Open API or API from a vendor or a partner, then that increases the costs of invoking the application. Additionally, if we want to do any sort of synchronization between the instances of any of that data that's being served up by the flight tracking API, that can be quite heavyweight. It's subject to latency between those instances, and synchronizing can be a little bit tricky, a little bit messy between those instances as well. So there's some examples of the problems that we're trying to solve with an event mesh today. So a solution with an event mesh would look similar to this. We've got a couple of APIs or microservices that we've created around the flight tracking API, and that is to pull the data once and once only. Once that data is sort of pulled into the application in Singapore and published as events to the broker hosted in Singapore, it's available in real time to your other brokers hosted in London and the US on different cloud brokers, cloud vendors. So that means you've got complete control over the number of API requests that you're having to invoke with your partner. And you'll see on the right hand side here we've got Apidays, which is our reference data lookup. It's just a second web service to demonstrate the invocation of a second web service with reference data and how that can be shared across those multiple instances as well. So happy to take any questions at this point. I can't see any in the chat, so I can move to the demo if we're happy to do so. All right, no questions so far. So I'll just jump over to the demo and walk you through how the demo is structured and what we're going to be demonstrating here, what we're going to be showing. So just to give you a bit of a visual as to how the brokers are distributed across the globe. We have three brokers, as mentioned. Amazon Web Services hosted broker in the US East, Flight Tracker Azure London, so the London broker deployed to Azure, and the Southeast Asia broker deployed to GCP. Now, the flight tracker app, again, this is hosted in Singapore. So we've got 3 instances just to roll through. Now, the connection details are up the top. We've got connection to the cloud URL, and the first instance of this flight tracker app is connecting to the Southeast Asia service. So I'm going to connect to this service now. And we've got a topic subscription window here, and we're going to use that to show you how the filtering works across the 3 instances. I'm going to click on the subscription, so it's ready to receive messages now. On the right-hand side of our flight tracker app, we've got a button for starting the feed from the OpenSky API. So this is basically just to show you that we are invoking the service, the microservice, once. For 10 minutes, it will poll the OpenSky API to pull in flight data. And then we'll use that single feed to show you how it's being propagated out to those other brokers. So I'm going to trigger that feed now. And we can see some flights appearing on the map. Now you can see here we've got the topic that the messages are being delivered to. Flight track plane update. The next node in the topic is the source of data. So this is OS. We've just got the single feed from OpenSky at the moment. And the final node in the topic is the flight code. So this is the topic that those flights are being published on. In the topic, we're actually using some wildcards. And those wildcards are they behave as you would expect normal wildcards to behave. For all of the flight codes that are coming through this feed, they're being displayed on this instance of our flight tracking app with the asterisks. So just one other thing on the right-hand side. So you can sort of join the demo if you want, scanning the QR code. That's going to pop up a window to show you our reference data application. And this will basically show the lookup data for the flight codes.
Yeah, I put the link to the chat box as well for people who are unable or having hard time to scan the QR code, but yeah, it should be quite easy.
Excellent. Thanks, Ari. Okay, so we're just going to jump to the second instance. Second instance, what we're going to do is connect to the Azure broker in London. Initially, I'm going to subscribe to the same topic. So we should be getting the same flight data come through without having to invoke the OpenSky feed. So we're not doing it a second time. We're utilizing the data that's been pulled through from that initial API invocation source. If you click on any of these flights, you will have the flight code appear on the right-hand side. So what I want to do here is limit the data or filter the data to a certain airline. So for this one, we'll take BTK as the first part of the flight code. And we'll use the asterisk for any BTK flights. And we'll click subscribe to that. The filtering has occurred, and you can see we've dropped down to just the 2 flights. So you can get very granular in terms of what data you want to subscribe to, even though the feed is feeding through a superset of your data. this subset is being sent or subscribed to by this instance of our flight tracking application. And something really important with this is basically your data is not needing to be filtered by your applications as they receive it. So the filtering is actually done at the broker, and we use technology called dynamic message routing to make sure only the data that is requested or that is subscribed to is delivered to that subscribing application. Okay, so I'll just jump over to the US East instance, and we will connect to the US East broker, which is hosted on AWS. And for argument's sake, we're just going to subscribe to all flights in the US East. So again, we're getting all flight data to that location in real time based on a single feed or a single series of calls to the OpenSky API that are being done. All right, so just one thing further with the propagation of that data out. For things like reference, this is good for streaming data and to help you understand how we stream data in real time between instances globally. But we're always going to have things like reference data, which is more static and can be used over a longer period of time typically. So I'll click the lookup airline link for this PKMBS flight. Right, some of these airlines have a little bit of an issue with displaying the data, but we've got Malaysia Airlines that has just popped up. So if anyone's out there and they've clicked on the QR code to have a look at the data coming through in the app, what you'll see is the link will connect you to a random broker out of those three that we've set up for the event mesh. And that Malaysia Airlines reference data will pop up based on myself clicking that link. So that data can be, again, requested once and then moved dynamically. Okay, and just if we jump over to, this is basically just a desktop representation of the app from that QR code. And you can see that Malaysia Airlines has popped up as reference data in London. Now the filtering is very dynamic and can be very granular. It can be as granular as you need it to be, or as coarse-grained as you need it to be, depending on your topic hierarchy and your topic structure. So that's the way it operates. This will probably shut down because I think I've talked for close to 10 minutes. But that's the flight tracking demo in a nutshell. So more than happy to take any questions at the moment. I think we've got a message that's come through from Queenie. Did you want to take this one, Ari?
Sure. I think while people are still looking at the planes, I'll take that question. So Solace, the broker, supports multiple protocols and APIs. So we do have our own Solace protocols called SMF, which is what we started with. But we also support multiple open standards or protocols, such as JMS maybe for Java Enterprise Systems, or MQTT for IoT solutions or devices, or mobile apps even nowadays. And we can do those over WebSockets as well. And we also support AMQP 1.0 and REST especially, I think it's important to mention. So you can publish events into the broker or into the event mesh. Like for example, you push the data to the Singapore broker with REST, simple HTTP post would do. And the consumer can actually consume or subscribe with whatever protocol they choose to use, right? They can use the one with WebSockets or the one with JMS. So we will do the protocol transaction as well. So just to add with what has been explained by Jason in the event mesh, to be able to support this kind of solution, we provide not just the dynamic message routing to have that smartness in terms of routing events across region, but every single node can support multiple different open standards protocols. So we kind of lower the barrier to entry for all applications. So if you have squads that are using their own stacks and maybe I just want to use Golang, for example, then we can use Golang with Solace API or Golang with MQTT or MQP or with REST. So there's quite a lot of options to choose. And if you guys head out to solace.dev and you can see how to get started with Solace Cloud, in there you can actually see later on how to connect with all these different protocols. Right, so I hope that answered the questions, and let's see if any other questions regarding the demo first. Okay, so additional follow-up questions. Yeah, so that's the subscriber part of the events. There are some applications that is not going to be able to talk with messaging protocols, right? Whether the native one or the open standards one. Maybe you have a REST API endpoint somewhere that needing to be called or needing to be invoked to give the data to that applications, or the newer one like cloud native services that we see now, all the serverless functions and stuff. So Solace supports that as well. So Solace can act just like a REST API client. When we have an event to distribute or to deliver to a particular client, and that client is a REST API endpoint or something like cloud native services, then we can just do a REST call to that particular applications to deliver that message. And so this simplifies stuff for a lot of our customers who say that, yeah, we do have a lot of subscribers, but some of them just we cannot change it. Right? We cannot touch it. We don't want to touch it. We don't want to change it, but it's available as REST API endpoints. Then we can use this approach as well. Right. So
Thanks, Ari. I'm just going to put, I don't know if you've copied this in, but I've sent the link if you want to have a play with the flight tracker demo yourself. I'll have it set up for quite a while. So, yeah, worth having a look.
Yes. So let's see.
Right. Did you want me to share, stop sharing, Ari?
Yeah, I think just to before we segue into my demo section, just to recap, like when we mentioned we have 3 nodes and we have traffic basically start publishing into Singapore nodes. So before anyone starts subscribing to the London node or the US East node, there's no traffic actually going through these links, right? The green links. Once somebody subscribe to London and say, I just want to see BTK asterisk, then what happened is some of the events will go across to London, because that particular subscriber is only interested in anything started, the flight code that starts with BTK. So let's say we have like maybe 100 event per minute on the Singapore node, but the one in Azure might only get like 20% or 10% of that traffic because there's only a handful of BTK flights available. Right? But if you subscribe to the whole wildcards, which is asterisk, and you will get everything, then you will have the whole data that coming through to Singapore will be streamed across to Azure. And same thing happened when somebody start subscribing in AWS in the other node, right? So that's the demo. The link is there in the chat box. Feel free to look at it and look at the airlines lookup as well. But yeah, I think let's jump into my section of the demo. Jason, let me share my screen if you can.
Sure. I'll stop sharing.
Okay.
You should be able to share from there, mate.
Yeah. So let me. So I'm sharing what we call the Solace Cloud Console now. Is the sharing okay, Jason? Just a quick check before I speak too much.
Yes, mate. Yep, all good.
Cool. Yeah. So yeah, I'm sharing the whole browser so I can move between tabs easily. Right. So let me go back to home. So all the nodes that you've seen before, the 3 nodes, is all of them are managed through this PubSub Plus Cloud Console. So it's not just the brokers. So if we talk about the runtime, we have the cluster manager to look at all those 3 nodes available, and then the mesh manager, which Jason has pointed out before, showing you the links between all these 3 nodes. But we also have the management or runtime. No, sorry, this is runtime and this is management or design time, right? So first I would like to go to the designer and see. Now this should help in terms of understanding what's really going on in the demo, right? You can have multiple application domain here. I only have one for now for this demo purpose. So we call that flight tracking demonstration. I hope this is not too small, but you should be able to see applications, these 3 circle and 6 events available in this domain, as well as the relationship between the applications and the events. Right. So with this, I would like to again come back to the Java program that we mentioned before. The dashboard is the web UI that we've seen just now, right? The one with the map and all the flying planes all over. We also have a Java program that deals with doing a REST API call to Amadeus test API, just to look up from the ICAO code what is the actual airline's name or the full name. So you can see like British Airways or Asia coming back from Amadeus here. And another Java program is for getting the data feed, the flight that we've seen just now moving around. So this shows that there's a event called feed available, right? If you notice, I mean, for people who with keen eye before, when Jason started the demo, the start button to start initiating the flight stream is not enabled yet, because the dashboard will kind of sends a request when it's subscribed to the Java program and asking whether it's available or not. So once we get that okay, then we can send this request. So that's the start button is sending a request to start a feed for 10 minutes for that example, right? Once the Java program gets that, and this one will run a loop for 10 minutes, just fetching the data from the REST API endpoints provided by OpenSky Network. And then those events will be parsed and then published as stream into the broker. And then the dashboard will subscribe to that one. Right, so quite similar to that. There's also an available status event coming out from the Java program for Amadeus to let us know that we can now do a lookup airlines. Then you start seeing the links lookup airlines on the side of the ICAO code of the flights. And then when we ask for a name, we basically send a request like this, and then we get a response back. So this is quite important because this is not like a REST API call where there's actually just one line. I'm asking and then you give me a result. This is done in an event-driven manner. So that's why if any one of you actually scan the QR code and look at the airlines, look up the small page, when Jason click look up airlines, you can also get the result. So for example, when I open this one, yeah, I also get this reference data, although I'm not the one who's initiating the request. So this is again to emphasize what Jason has mentioned before. Reference data are meant to be usually shared and not going to change that much often as well. So it's nice to be able to do PubSub for reference data as well like this. So coming back to this, yeah, this is event-driven manner of getting the lookup airlines lookup result, right? So just getting to a bit more deeper into this one, right? So we've seen the graph presentation of this domain. If we go into the events section, you will have a list of all the events that we saw, the 6 of them, and their topic address. Right, so topic address, you've seen it in the demo as well. By default, you should be subscribing to flight track plane update and then asterisk asterisk, meaning for the last two level, you don't really care where it's coming from. Is it OS or something else? And you don't care if it's BTX or SIA or AWX, for example. But at any point in time, you want to narrow down your interest into only BTX flight or BA flights for British Airlines, then you can put BA asterisk. So that's how the wildcards works. If you don't really care about the entire hierarchy on the right side, you just put greater than sign. That means I don't care how many levels are there. I just want to have everything, right? And then the others are quite simple. When I ask for availability status, I push into this topic, and then I get the response back in this topic. When I push for an airline lookup request, I push into this topic, and I got this result topic, right? Just bear in mind that we don't actually create this topic beforehand like how we would do in other brokers. So this is all metadata. So you can choose to put a lot of other additional fields later on without having to change the broker configurations. And then this also gives you the schema. Of course, if you need to see what the payload looks like, right, you can just, okay, of course you will see the overview first, the dates, who owns it, if you have tags available to it, and then any descriptions, and you have quick links for the publishing and subscribing applications. Again, this is useful if you want to make a change into this topic or events. You would know in a glance what are the applications that's going to be impacted, right? So just quick look at the schema. You can also, if you want, you can edit it here as well. There's also a quick validation tools available in this web UI. Right. So again, this is the topic name. One thing more to note is the fact that there's a shared events and there's unshared events. So we have a lot of no here and then one yes. And the reason why we want to have this as a yes, because later on we want to show how to expose these APIs, these events as APIs, right? So the next thing is, for some other teams, you might not really interested in the graph presentation, but more on basically searching for something, like trying to discover if you have anything about, maybe about flight code, for example. So you can just search, and you can search from all the domains or just from specific domains, or also can be from owners or shared or not. But this tool will allow you to search into details, like even into descriptions, into the names, into the topic display. So this one saying that I found flight code in the topic address, and I also found it in the flight in the topic level display. But if I change something to, yeah, maybe just text, then it will show you something else. So it's going to be useful for even data officers to find out if all the data flowing across the enterprise are all compliant to what the policy that you have in the enterprise. Right, so that's the other presentation of the same set of data. Again, you can choose to design first and then implement to runtime, or you can have the runtime already running. Even probably you have not just Solace broker, maybe you also have a little bit of Kafka here and there. You can actually scan those environments, right, and do this, and you can find, yeah, this is some of the old demos that I did in the other conference. You can scan a Kafka, you can scan a Confluent Cloud, you can scan something in Amazon, and you can have those events coming in, and then you can design it all together. So it's kind of giving you the full view, right? And then the last piece, which is the kind of the most important thing for this demo, is the API products. Right? So again, if you're coming from REST API, this is going to be something like very familiar. The idea is that we want to be able to bundle 1, 2, 3, or how many events available in your enterprise, and then you target that to a specific consumer, and then you bundle into one API product with the set of permissions and whatnot, and then you put in all the events that you want to be available in that product, right? And then when you started and it's not released yet, it's available internally for your internal team to start working with that. You can download the Async API specification or JSON or YAML, up to you, it's your preference. And then once we release that, then we can also have the option to run it, host it as a public website. So this should be familiar with people working with Swagger before. Again, this is taking a lot of ideas from the RESTful work from the Swagger from OpenAPI. So we are a bit later, but giving you the same set of functionalities, right? You want to document the events just like you document your APIs, your RESTful APIs. I mean, you can collaborate. You can start sharing the spec across. You can even host it like this, and people can download the Async API specification. Then you can also see the payload, the schemas, and also where to consume that event. So in this particular API product, I put the Singapore node as the place for you to consume. You can also choose to put any other thing, and I put, for this one, the protocol is MQTT. Right? So just to, again, to demonstrate that we can do other protocols, open protocols as well. So once you have that, you can just download the Async API specification, and then you can go to studio.asyncAPI.com, if I remember that correctly. And then just get this file and then drop it here to see the details, right? So this is all open source specification. You can play around with that. But then if you want to then share these events to the other partner, the external parties, we can also share that. So in that case, I want to start consuming these events with MQTT. So let me switch screen first and share another window, which is an MQTT applications. So I put in the information I found from the Async API. Then I get the credential from another manner somehow. Or you can use certificate or OAuth or whatnot. But for now, I'm just using the Solace username password. And then I connect that, and then I start subscribing. So when I subscribe, I can also subscribe to the similar topics that we've seen in the demo. But for MQTT, instead of asterisk, I need to use plus. So this is just the different ways of doing things with MQTT. So now, yeah, this is all the other events flight that we've seen before when we do before the demo, sorry. But now, because there is no flight data streaming, because of it's ended after 10 minutes block, it stopped. Right, so I will need help from Jason to kickstart again one block of requests, and we can see it's coming in here. While I also check for questions. Yep. So thanks, Jason. So now I don't have a map. That's obvious, but I get the data. I get the same data as what the other would have, and I can do this by connecting to the broker appointed by the specification. Right? So it's up to you to say that, okay, I have this bunch of brokers. Those are internally internal facing, for example, maybe it's just for your department, but I can have something out there on the cloud for my partners to consume, or for my partners that's there in Europe. But this is the partner from Southeast Asia, for example. Then I can do all this, and they will have this event streaming in a dynamic fashion. And so I'm not going to do synchronization of all these events across like 10 brokers all over the place. I have the links ready, I have the event mesh ready, but as long as there is no one subscribing to this particular events there, then the data will not just go across. So this saves you in terms of, of course, in cloud we talk about egress cost, and that is where we make it more efficient. So I'll pause there and see if any additional questions. Okay, there are some questions. You want to take the first one, Jason? Or
if you take the first one from John, Ari, and I'll take the one from Sky. I'm just sending one through text.
Yeah. So John, you asked what technology do you use to sync these brokers on the event mesh and storage application. So this is key difference with other technology we've seen before. When we mention event mesh, when we start talking about event mesh 3 years ago, the idea is really not synchronization. It's not replications. We don't talk about doing a volume block replications to other parts of the world. It's just not going to scale. So the links that we saw, I think Jason, maybe I can stop sharing and you can show us again the map slide while I explain.
Yep, sure.
So those links are what we call DMR links in Solace terms. So DMR links is what connects all these brokers together. And the idea is that I'm only going to push events across if there is a need to do that. So it's really on demand. It's really open. It's quite simple actually, and really based on what you subscribe on the other parts of the event mesh. And so this is DMR links. This is Solace technology. So I'm afraid you're not going to see this in other brokers. But then there is no Solace application because when an event comes in, the event comes in Solace can be a direct event or a guaranteed events, right? The guaranteed will need to go through this, the direct does not. But both can be streamed across all these event mesh. There's no problem with that. So we don't look at the underlying storage. We work on the broker level to see an event comes. Now, where do I need to route these events across to? If there's no one needing these events on AWS, then I don't bother sending it across. And if there is someone needing it in Azure, I'll send it across, and that's it. So it's kind of like that. So that's one part of the event mesh. The other part is we talk about running it everywhere. That means you can run it on Kubernetes, OpenStack, or VMware, also supporting different protocols. So you can say I'm pushing it as a REST post, a REST API, but my subscriber is using JMS and MQTT. Perfectly fine. So that's event mesh. That's two sides of event mesh. I hope that answered the questions. Jason, up to you for the next one.
No worries. Thanks, Ari. Yeah, so Sky's asked about if the publisher side's down, will data be still sent to the subscriber? How can this data be retrieved back? So if the publisher's down, that means Solace won't be receiving messages. However, if there's a subscriber, you've got a use case which requires data to be persisted, there are a number of options to be able to do that with Solace. So we still have the concept of topics and queues in terms of message distribution, and they can have their own different quality of service properties as well. So with persistence, anything that's delivered to those queues can be persisted for a set period of time. We can also configure the ability to do retries for those messages. So you can set a time to live parameter of, say, 10 seconds, retry attempt parameter of 5 times, and it will iterate through those 5 retry attempts, trying to deliver that message. If it doesn't deliver it, you've got options at that point as well. So is the message a candidate for being fine for discarding? If so, it will drop off the queue, and the next queued message will end up at the front of the queue. If you do want to persist those messages still, even though they've exhausted those retry counts and time to lives, you can configure dead message queues. So you can have a separate application or an exception management framework, which is listening to those dead message queue messages and dealing with those messages in an exception management way. So there's definitely a few options. There's the other option of using a replay. So we've got replay functionality in which messages can be sort of replayed from a point in time. So if you've got new applications that want to subscribe to certain messages and you want to sort of preload them with a week's worth of data, you can set up your subscription and then have the messages replayed from a certain point in time. And that's quite configurable as well in terms of delivery of those messages. So from a message resilience perspective, there's definitely a few options there. Over to you, Ari, for Queenie's.
Yeah, there's one more questions about consolidating events from managers into a single Kafka cluster. So to answer the question, I think I'll reiterate the concept that Jason was mentioning before, right? The whole idea of this thing is you have one REST API existing, available, or provided, whatever, but you want to be able to then leverage that in the event mesh, so you can have wider usage of that and supporting more and more protocols and APIs. Right? We talk about JMS, we talk about MQTT, REST, WebSocket, MQP, but yeah, Kafka is always asked as well because of this event-driven architecture craze now, right? And yes, the answer is yes. So let's see if in this picture, let's think if somewhere near AWS you have a big data solutions running there, and it's being fronted by a Kafka cluster, but then you will need to have all the events coming across from all three nodes. So maybe this is not just one API again, like flight tracking, but maybe a bunch of multiple applications running here and there, and everybody who doesn't even talk Kafka API, but needs to feed data into Kafka API. So what we'll do in this picture is we just kind of plug in the Kafka cluster into one of the nodes, or the other way around, depends on how you look at it. But we basically connect one of the node with the Kafka cluster. And then we say that, okay, we want to have this topic from Solace to be pushed into Kafka. Or in some other way, we said, you might want to do the other way around sometimes. You might say that I want to have that topic in Kafka cluster to be then on-wrapped into the mesh and then spread across the entire event mesh. That's also possible. So that is something we now call as Kafka mesh. I think if you folks saw our boss presentation yesterday talking about the API products, and of course we're going to talk about Kafka mesh quite a lot as well later on. That's the idea. We want to have the event mesh. It's not just the event mesh, but also leveraging the ecosystem. So if you have Kafka there, we can make it as a Kafka mesh where you have Kafka in one region, another Kafka in another region, another Kafka in another region. Could be from different vendor, for example. Could be some of you like do it yourself Kafka, but the event mesh in the middle will become the fabric to connect everybody, right? So we have 1 minute left. If there are further questions, just drop us a chat and we can get back to you as soon as we can. Yep. But I think last question from me is, and did you enjoy the demo? Let us know what you think, and hopefully this is going to be resonating with a lot of you folks who already have some REST APIs and wanting to get more benefit or leverage the benefits of event-driven architecture for your enterprise.
Excellent.
Any last words from you, Jason, before we need to close this?
No, I'd just like to say thanks very much for attending. I'll be in the booth, the Solace booth as well, for pretty much the rest of the day. So if you have any further questions, please reach out.
Yeah, and don't forget to sign up for EDA Summit as being there, share in the chat. There's going to be a lot of more other customers from industry to talk about more about even different architecture journey on their side. Okay, then. Thanks, everybody.
Thanks,
Cheers.
everyone. Bye-bye.
Bye-bye.